All right, we're back. We're on page 6 of notes 9 of Calc C, and we are going to talk about geometric series again because geometric series that we've learned so far are also power series, and we also know they're also Taylor series, so they got everything, right? So let's see if we can like manipulate them a little bit. I just think it's good practice. I mean, this kind of stuff comes up a little bit more than like this general power series stuff. So let's see if we can do it. So um, you can see it's a power series, by the way, because it fits the pattern, right? The pattern is you have some coefficient and then you have like power functions, basically. And so that's what we have here. And what we're going to do is you kind of look at this. The key part, like the most essential part when you are dealing with these is this one. The next most essential part when you're dealing with these is the minus. So my goal whenever I'm faced with this is to try to rewrite the thing I'm looking at, usually a rational function, try to rewrite it so it looks like I don't care what over 1 minus I don't really care what. Like that's my goal. So let's see if I can accomplish that with these things. So we want a power series centered at 0, which hopefully that just happens. If it doesn't happen, we'll have to like recenter or maybe make a table of values and like work our way through it. We'll see. All right. So our first goal is to get a 1. Our next is to get 1 minus. So first thing I'm going to do is divide everything I see by 2 because that'll give me a 1. So 4 divided by 2 is 2. 3x over 2 and then plus 1. Okay, that one got out of control because I got flustered by I get a little flustered when it auto shapes things, and then, I overreact. All right, now I'm going to rearrange this. I get 2 over, so I'm going to say, well, all right, extra steps. Now 2 over 1 minus negative 3x over 2. The minus and negative thing happens all the time. All right, so then this is geometric, where we have our first term. So this is going to be our first, this is our first term, so it's 2. And then our ratio is this thing. So get over here. 2, negative 3x over 2 to the n. So let's color code that, because I sort of think I've never gotten any feedback about this, but I think if I were looking at it, this would be helpful to me. I had like an Algebra 1 book at some point in my life, like way back when, where they did that. Like while they were solving equations, they like highlighted things and it like just clicked for me. Because I could just like, it's really easy to visually see, like, even if you don't care, you're like, why are these the same? Why are these the same? So good stuff. All right, so then, because I like to make this look better, make it negative 1 to the n, 3 to the n, oh gosh. Okay, so hold on, fraction. I forgot it was a fraction. Let's move you up. Let's put a thing there. 3 to the n, x to the n, over 2 to the n. And then, I'm going to clean that up a little more and say, because you always want to be thinking like, what would this look like in a textbook or, on an AP exam? Like what would they have done here? I think this. All right, so we also know that the absolute value of r, so the absolute value of negative 3x over 2 has to be less than 1. And this is this again, color coding. All right, so I'm going to multiply by 2 and divide by 3 and say the absolute value of x has to be less than. Multiply by 2, 2/3. So over here, we'll do comma. The absolute value of x is less than 2/3. That should do it. Do we want to look at that? So I think this is like a really good thing to do, is to take a look and just see like what are these things? Like how do they work, right? So calculator page. So really I should do it on a graph page. So doc for graph. I'm going to graph the original, 4, 3x plus 2. So I think that the thing that I've written will only really apply between negative 2/3 and 2/3, which kind of makes sense to me. So I'm going to do a summation. Let's say we use, you got to make a choice. I'm gonna say we use like 20 terms. So we'll go from 0 to 20. You can't really put infinity. The calculator doesn't know actually how to deal with that. And then I'm gonna put my most expanded form, which is definitely annoying, but like I wanna check my answer. I don't wanna check like my initial response, like my unsimplified thing. Here we go. This should be good between negative 2/3 and 2/3, but like only there. So let's also, I don't know what I'm saying. Negative 2/3, negative 2/3 to 2/3. Should I give that a little padding? I don't think so. There you go. That looks pretty good. You see it peeling away there? That's because we didn't do an infinite number of terms. And also it diverges at 2/3 and negative 2/3, right? Geometric always diverges at the endpoints. There's never any point in doing the ratio test, right? When you have to do the interval of convergence, never any point in doing it on a geometric. It will always fail at the endpoints. But if you don't remember that and you do it, you'll just, as long as you do it right, you'll get, oh, it failed at the endpoints. Like, not a problem. So we got it. All right, let's try this one. Hoping that this factors. All right, I hate when the leading coefficient is negative, so I'm just gonna flip this up. And then does that factor? Negative. It's like you get to this point in your math career and you're like, yeah, I'm so good at everything. Then you got a factor and you're like, crud. Plus 7, x minus 1? I think so. All right, so we do have some factoring, some canceling rather, which is good because I was kind of hoping that would happen. So I have negative, okay, so that's gonna be negative, I gotta sneeze. Woo, excuse me. X minus 1. This is perfect. I'm going to take the negative and distribute it in the denominator. Boom. All right, and then that's going to be, that's it. That is the geometric series. That's just x to the n. And r is just x. Oh, do I have to sneeze again? Oh. Wow. I was reading on Reddit yesterday, and there was like maybe it was like an Ask Science or just Ask Reddit. I don't remember. That was like, why does it feel so good to sneeze? And just like everyone else, I read like the question and I never read the answer. But when I read it, I was like, yeah, that's true. It feels really good to sneeze, and it feels terrible in the lead up. And then if it doesn't happen, you're just like, why is my day ruined? So I'm gonna check this one, and then maybe come back in the next video and do the next ones. I'm gonna not check this one because I'm pretty confident on it, and I'm just gonna do this one. You should check it though. Check it the same way, right? Graph it, or alternatively, have the calculator just write the Taylor series, right? Like I don't remember the commands, like menu for up a bunch of times, Taylor series, and then punch it in. It'll do it for you. This one's going to be straight-ish forward as well. So what I'm going to do is, you kind of have a choice. So what I like to do, what do I want to do here? I'm just going to go for it. Well, so now I'm literally just rewriting. Okay. Is this allergies? I don't know. Okay. This is going to be my first term, and this is going to be my ratio. I don't know. Okay, so I'm overcome by allergies. I have all the windows open, like all of them. So it's the first term, 2x squared, and then the ratio to the nth. This is r. This is our first term. I mean, this one was already written in kind of like a perfect form for us. So n equals 0, it's going to be 2. It's x squared, x to the 2n. So I'm going to say x to the 2n plus 2. And then we need an interval of convergence. So the absolute value of x squared has to be less than 1. Sometimes people find that confusing. So, and when I say that, I'm probably talking about me. So what I do is I just think graphically about this one, right? So if I had x squared, right? So this is x squared. And I need the absolute value of x squared to be less than 1. So like this is 1. So if I go across, here's 1, here's -1. So any value that's in between -1 and 1 will work. I don't know, like for whatever reason, I get confused by that. So I'm going to say the absolute value of x has to be less than 1. And it's okay. Sometimes you just got to admit when you find something a little confusing or whatever. So now I only have 2 left, and I feel like that's a bad split. So I am going to check these. Here we go. Ready? Calculator. Let's check the first one by having the calculator find the series. So menu for up, and then option C, Taylor polynomial of, oh my God. I really gotta, I don't know, blow my nose. I take allergy medicine, so you would think it would like knock this out, but you would be wrong. Let's do like 10th degree, and I think this is gonna be 1 plus x squared plus all the way up to x to the 10th. And it is nice. So it's weird, right? Like, because there's that extra factor and we canceled the extra factor, and like that factor would have given us a problem at -7, but that's not in the interval of convergence. So like, you know, we got it. Let's try the other one, just having this guy do it for us. 1 minus x squared, x, 10th degree, I guess. So then like the issue is you then have to like know if it matches yours. So one option is just type in what you have. So I need to only go up to the 4th according, if I want to match what I have there, 2x to the 2n plus 2. And it does match. So you run into this weird thing. When the calculator does a series, a Taylor series, it understands that normally what we do is we write them from the lowest degree to the highest degree, because to add more terms, you just put them at the end, right? Which would be the right-hand side. When it does a summation, it's not thinking of series, it's just thinking this is a sum, and it puts it in the order that you were taught to put it in when you're in like algebra 2, which is from highest to lowest, which, you know, whatever. I mean, it's just like a fact of life. But I always find that a little interesting, that it like kind of knows what to do. All right, I'm gonna go back to the notes. So we got those right. Could have done it graphically. Graphically, you get to see the picture. I think the visual of that, I think, is underrated. Maybe it's underrated partly because people like me don't show it enough. But anyway, so take a look at the visual. I'm gonna end this video here, be back, do the next 2 in probably a short video, but who really knows? So see you there.